Fundamentally, a commercial helical pile is a massive engineered steel screw driven deep into the earth. But unlike concrete, it's ready to bear the full structural load the moment installation is complete. No waiting. This speed isn't limited by the calendar. Work proceeds year-round, even in freezing weather that halts concrete pours. The entire process is accomplished with minimal noise, vibration, or site excavation, making it ideal for urban areas. So how does this work? We'll break down the core mechanism, its powerful applications, and the one factor that determines success. The most immediate advantage is dramatic project acceleration. Installation can often be completed in hours, not weeks. This speed is amplified by smaller, more maneuverable equipment, which means smaller crews and simpler site access. While material costs can be higher, the savings on labor and time often make helical piles the more cost-effective option. So it's fast and often cheaper, but how is quality guaranteed on the spot? How is stability confirmed without testing? The answer lies in a concept called installation torque. But what is this force actually measuring, and why is it so critical? As the pile screws into the ground, the soil resists its rotation. This resistance is the torque, measured constantly by the drive head. Here is the central insight. There is an engineered correlation between the final torque and the pile's load-bearing capacity. This process has been perfected with modern digital monitoring. These systems provide highly accurate, continuous readings. So, torque isn't just friction. It's actively proving the foundation's capacity as it's being built. Quality is confirmed in real time. With this level of precision, what happens when the ground itself is the problem? This is where helical piles become a primary solution. Challenging soils aren't an obstacle. Helical piles are designed to bypass weak upper layers to anchor deep into competent strata. Consider expansive clay, which wrecks conventional foundations. Helical piles bypass this active zone, anchoring in stable soil below. This isn't done blindly. The real-time torque feedback tells the installer exactly when they've hit soil with the required capacity. This adaptability applies to more than just buildings. Think industrial equipment pads, solar arrays, and bridge abutments. Their helical plates also provide powerful resistance to tension and uplift, vital for towers and structures in high wind zones. This combination of speed and adaptability seems almost infallible. But what are the real-world risks? Where can it go wrong? First, the material itself. The piles are manufactured from high-strength steel, typically galvanized for corrosion resistance. This creates a paradox. The material is incredibly strong, yet failures, though rare, can occur. If the steel doesn't fail, what does? The single greatest risk in any helical pile project is human error, like installing to the wrong depth or misinterpreting torque data. This reinforces the central importance of installer expertise and the precision of the torque monitoring we covered earlier. And while the monitoring is modern, the technology is not new. It was invented in the 1830s for lighthouse foundations. So if the tech is proven and the deciding factor is precise installation, let's connect all the dots to see the complete system. The incredible speed of installation is made possible only by the real-time quality assurance of torque monitoring. The ability to defeat bad soil isn't guesswork. It is a direct result of that same data-driven torque feedback from the machine. And the environmental advantages, minimal soil displacement and less concrete, are the natural outcomes of this efficient process. Therefore, the entire value proposition, from cost-effectiveness to performance, hinges on installing with data-driven precision. We've seen how helical piles offer immediate, permanent strength that is verified, not assumed, during the installation itself. They adapt to nearly any challenge, difficult soil, tight job sites, and year-round weather, while minimizing site impact. Commercial helical pile installation represents a shift to intelligent, data-driven foundations that deliver certainty and speed. For your next project, the question isn't just what foundation to build, but how to build it smarter, faster, and with more confidence.